The cassette interface board for this Altair 680 computer could load 8K BASIC in about 13 minutes, as opposed to the 35 minutes it took with paper tape and a teletype. Of course, 35 minutes is just ridiculous. That makes, to me, it makes the computer pretty much unusable for using it with BASIC. And 13 minutes is better, but even that's a long time. By the time you then turn around and load a program to use, you probably spent 15 minutes just getting your computer booted and running. Now over on the Altair 8800, that same process with cassette loading the same size BASIC took a little bit under 5 minutes, so even faster. And the reason had nothing to do with the 8800 computer versus the 680. Instead, it was because on the 8800 they used a binary format for the data on the tape, whereas here on the 680 they wrote it all in Motorola S records, which is an ASCII format with a lot more overhead. Really gets in the way on a long program, especially at slow baud rates. Now, in another video, I demonstrated how a user back in the day could have written BASIC out to tape in that same binary format used for the Altair. And at that point, you could load 680's 8K BASIC in under 5 minutes as well. If you want to take a look at that video, I've put a link to it in the description for this video. All right, so again, 4 to 5 minutes, 4.5, 5 minutes, that's not bad. This is beginning to be a workable system. Now, to support the cassette board, Altair or MITS did release an updated version of 8K BASIC for this that added 2 commands to support the cassette, a C-load and a C-save to load and save programs and data. Other than that, it was the same BASIC. Now, unfortunately, as far as I can tell, they never did release a cassette version of the assembler editor package. They had a decent editor assembler for this machine, and it's a shame they didn't do that because there's more to life than basic programming. All the fun stuff comes with assembly language. So what we're going to do in today's video is try to create a cassette version of the assembler editor package for this to round out that product line. All right, I have the editor assembler loaded, and so now let's go ahead and just use it and see where we would want a cassette save or cassette load option as part of this. I have an empty edit buffer right now. If I wanted to input a program from the keyboard, I'd use the I command. And now anything I type after this is going to go into the edit buffer. So let's go ahead and type a little program. They all have to start with the name directive. And I want this to go into RAM, so I'm going to use the opt-m directive. And I'll put this up at 3000 hex, which will be above the editor and assembler. And let's see, let's have this program just write a letter out to the screen 20 times. So I'll use A as a loop counter, and I'll load B with a character to type. Let's just do a C. All right, and then I'm going to write a loop. Oops, let's see, delete, I think it's Control A. And we'll just call the monitor, which has an output the character in B function, at $FF81. So that outputs the C. We'll decrement the loop counter. And if it's not 0, go back to loop. And then when it's all done, we'll just jump to the monitor input line, which is command line input, which is FFAB. All right, now you've noticed I've been hitting return on all these lines, and it doesn't terminate the I command. I haven't gotten back to that ampersand prompt. And that's because character turn is not a terminator for the editor. Instead, hitting escape twice is what terminates all commands. So I'll do that. We've exited the I command. Now we're back at the prompt. So I'll begin 99T. Type 99 lines from the beginning, hit escape twice, and it'll execute it. All right, and here's our program. So that should work, it looks like. We can go to the assembler and try it here in just a minute. Now, how would you input a program from tape, a source file? Well, you use the same mechanism. Basically, on a teletype, you would type the I letter, and then it would expect it to come in through the console, what you were going to put in like we just typed it. Excuse me. But instead of typing it, you just put paper tape in and start it, and it comes in through the console just like you were typing it. Once the tape is done, you hit escape twice, and boom, it's in there. Now, there are other ways to load it, but that would be one of the most common. So we want the I command to also input from the cassette port. So that's how we want to do some input, is that I command to be able to load source files. All right, now you want to save this out to tape. On a teletype, you would hit E, and then you would turn on the punch and hit escape twice to execute it. And that dumps the entire edit buffer out to tape. Of course, that's going to be at 110 baud punching to the teletype. Here, we want that E command to go to the cassette. So there's another point of entry we want. We want the E command to go out to cassette. We want the I command to accept input from cassette. Now that I command also has to still accept it from the keyboard because that's obviously how you type it in as well. All right, so let's go see what the the assembler would need. To go to the assembler, you type G, and no, don't overwrite it. You run the 2 passes manually. There's first pass, second pass with a list. Okay, there we can see our program all assembled. So let's go ahead and go out to the monitor and run our program. Let's see, it output a bunch of M's instead of C's. I didn't put an immediate sign in front of the C, so it's loading from address 43, not the character 43. Let's go back to the editor, and let's fix that. So change quote C to # quote C. All right, that looks better. Go to the assembler. No, first pass, second pass with a listing. Exit to the monitor, jump to 3000. All right, there's our C's. Okay, so we can go back. Let's see, I think this will take me straight back into the assembler. All right, now you've got this all working and you want to punch the S record output from this assembly to tape so that without having to load the assembler or anything, you can load this tape anytime you want it. To do that, you use the 2T command to go to tape and hit return. Now again, on a teletype, you would have typed in 2T, turned on the punch on your teletype and hit return. These items would have then been punched to tape. You'd like to turn it off quickly not to get this on the tape, but that's going to end up on there partially until you turn the punch off. But it doesn't really matter because the operation terminates with that S9. What we'd like to, though, is for 2T to also go to cassette for us, because we want to be able to send these S-record tapes files out to cassette for our executable programs. All right, so that gives us 3 main things we want to do with the cassette. We want the I command to accept input from the cassette and the console. We want the E command in the editor to output to cassette so that we can save source files. And then we'd like this 2T command to also output to cassette. So I'm going to do a video cut and I'm going to reload that source file into this editor assembler and we'll take a look and see how that works. Alright, so I've got the source code for the patches I've written loaded into the editor assembler. These patches will make the editor assembler work with cassette like we just talked about. Now I've put these right at the end of the editor assembler, which is 1C81. That's the last, just past the last address in the editor assembler code. And that's normally where the edit buffer starts. But I'm going to have the edit buffer start up at 1CD8 to make room for this patch code. And I'll show you how we made that happen in just a minute. Right, so the patch consists of 2 flags that we're using. Punch flag is basically writing to cassette. I'll tell you why it's called punch flag later on. And then I have an input flag or an I flag saying that an I command is in process. And these 2 flags will let an input character and output character routine know what device to use. Should it go to the console or should it come from the cassette? Now, what we've done is hooked the input routine for all input. It's just a common routine in the editor assembler, and we have that right here. And likewise, we've hooked the output routine. All output goes through a common point, and we'll look at that in just a minute. So right now, we're going to return the byte from the console or the cassette instead of just from the console. Now, if it comes from the cassette, I only return it if an I was the last character typed on the console. Otherwise, it just pulls it off the UART so that it's gone and then trashes it. The reason for this is because when you start the tape, it ends up generating a garbage character or 2, and that garbage character could cause us problems. So the way this is going to work is anytime you want to do an I command and load, you'll start the tape, type I, and then it will accept only new things. Anything that came before the I, for example, when you started the tape, will be thrown away. All right, so here we're looking at the console to see if there's anything, and if not, it's then going to jump to the cassette to look. We'll look at that in just a minute. Otherwise, it gets the character from the console and then sees if it's an I. And if it is, it sets that I flag. Otherwise, it leaves that I flag clear. Oops. All right, and then if it didn't find anything in the console, it checks the cassette to see if there's something. If not, it goes back to the console check. And so it's looping looking at both ports the entire time. Now, if it does have something in the cassette, it gets the byte and sees if we are in an I command. And if it is, excuse me, if it's not an I command, then it throws the character away because it was probably garbage. Otherwise, it returns it. So it can return a character when you're typing it, or it can return a character here if an I command was the last thing typed on the keyboard. So data is coming in from both of them basically all the time. All right, let's look at the output routine. Whoops. Where am I? All right, so the output character routine, again, intercepts all output going to the console. We want to direct some of that to the cassette. So we're going to write it to the console no matter what. So we can always see what's going on the screen. And then we see if the punch flag is set. If it's not, we just exit, just go into the console. Otherwise, we wait for it to be ready to accept a character and send it out to the cassette too. That's all there is to that. So at this point, now all we have to do is set that flag and clear those flags. We already done the I flag up in the input character routine. So let's see. So when we start an E command, which is how we punch a source tape, we set that flag to 1. So now anything that's going out is going to go to the cassette too. When we're exiting the E command, we set that flag back to false so that now it no longer goes to cassette. All right, and then we have the same thing down here for the, let's see, what does that say, 16 lines? For the 2T command in the assembler, this is where we're punching a tape. So if it is a 2T command, then it goes ahead and it sets the punch flag to non-zero. So it will go out to the cassette as well. Otherwise, it's going to turn that flag off at the exiting point of the 2T command. So at the start of the 2T, we turn on the flag. At the end of the 2T, we turn off the flag. All right, so as far as our patches into the actual editor assembler, these first 3 are changing our end address, or actually the start address of the edit buffer to 1CD8 to make room for our patch. Now, interestingly, it's either 1CD8, 1CD9, or 1CD6. Those are all referencing 1CD8. They're just indexed slightly different in those 3 routines. All right, here you see the hook where normally it would do an input from the console. We're jumping it to our input character. Here's where it normally would go out to the console. We're hooking that to our output character routine. And then here's the hooks at the start of the 2T command for the assembler and the exiting of the 2T command for the assembler. And here's the hook for the start of the E command in the editor and the end of the E command in the editor. And on a minor note, I basically just disabled the routine that punches 50 nulls before a tape and at the end of a tape. Because going to cassette, we don't need that, so why bother? All right, if any of this looks familiar to you, or even if it doesn't, the reason is because all of this code is basically the same as what I did for the paper tape where you saw me flipping the switch, or it really looks a lot like the one where I didn't have to flip the switch, where I used the UIO board to go to the high-speed reader punch. And to make this cassette version, it was literally just a few minutes of changes. The main thing I had to do was add that input flag because of the noise, the bad character that a cassette could generate. Paper tape reader never generated a bad character because it always starts on byte boundaries, whereas cassette will start in the middle of a character on average and generate a garbage character up front. If you want to look at these sources in a cleaner, modern format, I put a link to them in the description field under this video. All right, so I have this patch, and now we need to test it and see if it all works. So I'll do a video cut and get this loaded in here, and we'll see if it all works and go from there. All right, if I really go through all the steps I had planned on, this video is going to be way too long. So I'm going to skip straight to the step where I tested it, it all works. I wrote out a boot tape, so now we can start from scratch and load the cassette version of the editor assembler and see how it all works. Now I wrote this tape using the binary format that we discussed earlier, and I've demonstrated in other videos for BASIC, so that it loads in about 4.5 to 5 minutes, so quicker than the 13 minutes it would otherwise load. All right, so let's go ahead and turn on the computer, give it a reset, And now we want to load the first stage loader from tape, which is written in S-record format, which is the standard format that the L command uses. However, since it's coming from cassette, the L command won't work because it wants to go through the console. And with the cassette interface, you always got a ROM, and when you jump to that ROM, it does the same thing as an L command, but it comes from cassette instead. That ROM is at FD00, so I'll jump to that, and then hit play on the cassette, and now it will load whatever's first on the tape. What's first on the tape, again, is a small binary loader in S-record format that once it gets loaded, we're going to have to jump to it. It's at 3F00, so as soon as I get my dot prompt back, there we go. Now I'll jump to 3F00. Now the binary loader is running. So going to FD100 loaded the first stage loader in S-record format, nice and small and quick. And now the binary loader is running, and it's going to load the editor assembler off the rest of the tape. It's given us progress here. Every 100 hex bytes, it's given us an indication of where it is. Now this editor assembler is pretty much the same size as BASIC. It's about 1C 100 bytes, a little over. So we've got a ways to go. So I'm going to do a video cut as we get near the end, and then we'll finish up. All right, this is getting close to finishing. Again, when we use this binary format that was used on the 8800, there's a jump record in it. So this is automatically going to jump over to the editor assembler and start it when the tape is completed. So that should be happening any second now. All right, there we go. So again, that whole process took just under 5 minutes to load the editor assembler from cassette. So huge improvement from 35 minutes. All right, so let's go ahead and try using this. First thing we want to do is verify that we can still type into the editor using the I command. Whoops, because we modified that. So let's type line 1. This is line 2. Type that all out. So yes, typing in from the keyboard still works. Let's delete all that. All right, so that's all gone. So now what we'd like to do is try loading from tape. See if we can load a source file from tape. Now I've already written one out there. It's the hello world that we've done before. Let me advance the tape to that. It's a ways up here. So sorry, this will take a second. Well, not too long. We're almost there. Or not. There we go. All right, so what we said in order to use the I command is that we want to release the tape so that it's playing. So I'll do that right now. So that's now playing. Then you type I. Now what's happening here is that the patch we made takes input from the console or from the cassette interface port, both at the same time. Right now it's seeing data coming from the cassette port. So we're seeing it come in at the cassette rate of 300 baud. It's kind of nice being able to see this come in. In BASIC, of course, we didn't see anything come in. So here you get an idea where it is. All right, that's all done. Hit escape twice. Stop the tape. All right, so at this point, we have got an editor with our program in it. All right, so let's go ahead and change it so we do something different. This says hello world. That's relatively non-ambiguous. I've done this mistake before. It shows up in a few places. So let's change FCC hello to FCC goodbye. All right, so now our program says goodbye world instead of hello world. So now we know it's different. Let's go to the assembler, run the first pass, run the second pass. Oh, it's getting errors because I did not set a new memory limit. So let's go out to the the monitor. So right now it's using all the way up to 7FF as memory for the assembler. We're assembling this at 3000. It doesn't like it. So we need to be below the 3000. So we have 2FFF is the address that is the last address used by the editor assembler. So now we're allowed to be at 3000. All right, so let me go, I think I can jump straight to the assembler. All right, so now it's not complaining. All right, exit, jump to 3000, let's see if it works. Now it says goodbye world. Okay, so it works. Let's go back to the editor. So you're happy with your program and you want to save it now. Again, that's the E command. So let me advance the tape to a spot where I can save it. And I have to swap the cables from the record position on the back of the computer and on the cassette player, because the Altair cassette didn't work too well with two cables plugged in at once. All right, so let me go ahead and start recording some idle leader. So we'll let this go for 2 or 3 seconds to allow that. And now we'll do the E command. And again, this now sees that it's going to cassette, so it is going out at the rate the cassette can accept it, which is the 300 baud that you see here. And this is saving our source file. And again, we get to see it going by, so we can see the progress. This is kind of nice. All right, so that's all done. We stop the cassette. All right, and now let's say you also wanted to save that S-record file, so you could run the Hello World program straight from the monitor without even having the editor assembler loaded. So let's go back to the the assembler. All right, so now what we want to do is a 2T command. And then the 2T should write to cassette as well. So let me advance to a spot to save that. And I'll start recording some idle leader for a second. All right, so now let's output that to cassette. And again, you can see this is going at 300 baud as well because it is going to the cassette. All right, so that's done as well. All right, let's go back to the editor. Delete everything. Okay, that's all gone. Let me rewind the tape to where I think I put the new source file. All right, now we switch this back to playback on the cassette and on the back of the computer. Okay, so now we let the tape run. We type the I command, and now it's taking it from the keyboard or from the cassette. Here you see it coming in from cassette. So hopefully this is the one where we said goodbye world. $300 baud in fast, but it is better than the teletype, and this is a lot quieter. Hopefully this has our goodbye world in it. Yes, it does. So that's the new one we saved. So that worked. So let's just do one last demo. I'm going to kill power to this computer. Turn it back on, reset it. So now we're just up in the monitor, and let's go ahead and load that S-record tape that is the executable program itself. Again, you would not have had to load BASIC or load assembler or anything. This would be just a cold machine. Now you can load an assembly language program. So I'll hit play over here, jump to the L command for cassette, which is FD00, and it's going to load this S-record file, and hopefully, there, we got our prompt back. So now if we jump to 3000, we got our goodbye world. All right, so there we go. We have got editor assembler that can load in under 5 minutes. It works with cassette for loading, of course, but also works with cassette for loading source files and saving source files, and saving S-record executable files. All right, so don't know if this is how MITS would have implemented it in the day, or if this is how it actually was and we just have never found a copy for it. I've never seen ads for it either. But now we've got both Altair cassette basic for the 680, and we have editor assembler for cassette for the 680. Again, I'll put the links to source files for this up in the comments field, and you can also for the video, and you can also have links to those 3 videos about the high-speed reader that I mentioned, which will cover a lot of the same kind of things we did here. And the work I did there is what made it easy to do this cassette interface patch.